Section 3.3, the slope of a line. Now, we have said before that we can uniquely determine a line given 2 points. There's 2 pieces of information about the line. How many lines exist in the plane of this whiteboard that pass through those 2 points? Just that one line. So 2 points is enough information to determine a line. But what if I say, how many points are there? How many lines are there that pass through this point and meet the bottom edge of the whiteboard at a 45-degree angle? I'm calling this a 45-degree angle. If I were talking about this, I would call that 135. So how many lines are there in the plane of this whiteboard that will pass through this point and meet the bottom edge at a 45-degree angle? Just that one. Just that one. Again, I have 2 pieces of information about this line. I have this time a point and what I might call its steepness, how steep the line is. And that's enough to lock down exactly which line it is I'm talking about. Now, we're not going to call it steepness. We're not going to talk in terms of degree measures or angles. We're going to talk in terms of slope. So what is the slope of a line? Well, here at the beginning of the section, page 224, just a little below center of the page, it's right above the last paragraph, or the last 2 paragraphs on the page. It says slope equals. Slope equals the vertical change in y, that is the rise, over the horizontal change in x, that is the run. It is the rise over the run. In the brown box at the bottom of this page, it says the slope is a single number that allows us to determine the direction in which a line is slanting from left to right, as well as how much slant there is to that line. And this can all be determined from the rise over the run. On page 226, she gives us the slope formula. So we already have this idea that the slope, we're going to call the slope m, is the rise over the run. She goes on page 226, in the brown box, center of the page, to say, well, this is the change in the y values from one point to another on that line over the change in the x values. Meaning, if I have 2 points, it is the difference in their y coordinates, y2 minus y1, over the difference in their x coordinates, x2 minus x1. Let's get a feel for this by finding the slope of a line. And let's just pick some pair of points to lock down a line. Let's say that we have the point 1, 2, and perhaps the point, I don't know, that might be what? 5, 3. So we're talking about this line. And I want to know the slope of that line. Well, the slope is the change in y per change in x. Call one of these points your first point. Call one of them your second point. I'll do the one on the left here as my first point. Call that x1, y1. And this guy we'll call x2, y2. It doesn't matter which one you call which. You'll get the same answer either way. So plugging into our formula, we have the difference in the y's. That's going to be the 3 minus the 2. 3 minus 2. Over the difference in the x's, 5 minus 1. That'll give me 1 over 4. And so my slope is 1/4. What does that mean? Well, we can think of this as rise over run. In which case, we're saying every time we go what? Up 1 unit, we go over 4. Up 1 over 4. And that gives me the slant of that line. Common mistakes. Putting the x's on top. As well as reversing one of your differences. For example, if I put 3 minus 2, but then over 1 minus 5, subtracting my x's the other direction, I would have gotten what? 1 over a negative 4, a negative 1/4. These make great multiple choice problems. There's the right answer. Someone is going to put the x's on top and get what? 4 over 1 or positive 4. Someone's going to swap one of those differences and get the opposite of what they should have. Someone's going to make both mistakes. And then, of course, E could be none of these. So these make good multiple choice items. Let's do another one. Remember this figure and remember our slope. And now let's look at number 36. We'll grab one from the homework set. We don't have a picture. All it says is we want to know what is the slope. It says find the slope of the line passing through each pair of points. And in number 36, the pair of points, -4, 5, and -5, 8. The slope is the change in y's per change in x's. And notice those are subscripts. That's not x squared. That's x sub 2. All right? So don't write those up in the air like exponents. Again, it doesn't matter which one of these we call our first point, which one we call our second point. Call this your x1, y1. Call this x2, y2. Just be consistent. In other words, we're going to be subtracting the y's, this one on the right minus that one on the left, so the x is the same way. The one on the right minus the one on the left. So we can plug in. The way I have it labeled, we've got 8 minus 5 over -5 minus -4. That's going to give me a positive 3 over, make 2 marks, -1 or -3. So there's my slope. This time the slope's negative. What does that look like if I just show a very rough graph over here? We have this point -4, +5. -4, +5, maybe about right there. And then -5, +8. Something like that. Well, now I have this line, and notice that it falls as we travel from left to right. This line falls. What did our other line do? Our other line was rising from left to right. It was rising as we went from left to right. And what kind of slope did it have? It had a positive slope. My interpretation on this negative slope, we can think about this a couple ways. We can call this a 3 over a -1 like it was, Or I could call it negative 3 over positive 1, meaning what? Every time this line goes up 3, it goes back 1. It backs up in the negative direction 1. Every time we go up 3, we go back 1 to land back on the line. Or what does this say? Down 3 over 1 in the positive direction. Down 3 over 1. Down in the negative y direction, over in the positive x direction. And that still lands me right back on my line. Okay, so far we've noticed that one of our lines was rising from left to right, and it had a positive slope. We saw one of our lines was falling from left to right, and it had a negative slope. I've got to wonder, what happens if we're talking about a horizontal line? Say the line that passes through 3 on the y-axis. Well, let's grab a couple points off this line and see what the slope is. Obviously, right here is the point 0, 3. And we'll grab us another point out here somewhere. Maybe the point 2, 3. This is the horizontal line that passes through 3 on the y-axis. So the equation of this line we know is y equals 3. That's the equation of our horizontal line. And what does my slope formula tell me about this? The slope is the change in y per change in x. The difference in the y's is 3 minus 3. The difference in the x's, 2 minus 0. That's going to give me 0 over 2, or 0. So let me get this straight. A line that rises from left to right has a positive slope, and a line that falls from left to right has a negative slope. And then we've got this line that neither rises nor falls as we go from left to right. Neither rises nor falls, and its slope is neither positive nor negative. Nice. All horizontal lines have a slope of 0. Well, then what about a vertical line? If I have some vertical line, let's say I have the line that passes through 4 on the x-axis. Well, you already know the equation of this line. Every point on this line has an x-coordinate of 4. The equation of this line is x equals 4. If we grab a couple points, say right here, the point 4, 0, and some other point, maybe here at 4, 2, then the difference in the y's, let's go top minus bottom, 2 minus 0, over the difference in the x's, 4 minus 4. That gives me 2 over 0, which we know is undefined. Division by 0 is undefined. So this line that is both rising and falling at the same time has no slope. Saying no slope and saying a slope that is undefined is the same. You will hear me say no slope more often because that's what I learned. But it is the same thing. She, in the book, will say this has a slope which is undefined. All vertical lines have slopes that are undefined. Or I might say they have no slope. Please notice that no slope, having no slope, is not the same as having a slope of 0. We have figure 26 here at the bottom of page 228. Which is basically a prettier version of what I have here across the top of the board. We have a couple brown boxes as we head that direction. Back here on page 227, brown box toward the bottom, a line with positive slope rises from left to right. A line with negative slope falls from left to right. On page 228 here toward the bottom, above this figure, a horizontal line has slope 0, and a vertical line has an undefined slope, or you're welcome to use the term no slope. Let's do another one of these, but let's crank it up just a little. Let's jump back to the homework and grab number 42. You know I can't pass up a problem like this. Number 42. Find the slope of the line that passes through this pair of points. Negative 4/3, 1/2, and 1/3, negative 5/6. First of all, do you expect this to be a positive or a negative slope? Just kind of think about what this looks like. A negative comma a positive? In what quadrant is this point? Where x is a negative and y is a positive? X is negative, y is positive. That's somewhere here in the second quadrant. And I'm not attempting to depict those points accurately. I'm just looking at quadrants. And a point that is positive comma negative. A positive x and a negative y. Over and down. That's going to be somewhere here in the fourth quadrant. And so I see my line is going to slant down or fall as we proceed from left to right. I would expect my answer to be negative. The slope is the change in y per change in x. We plug in. I'm going to call the first point my first point, the second point my second point. In each case, I'm going to be subtracting the right coordinate minus the left coordinate. So my difference in the y's will be this negative 5/6 minus 1/2. Over my difference in the x's, taking that the same direction, will be this 1/3 minus the negative 4/3. Now crank it out. Well, here in my big numerator, in order to subtract these two little fractions, I need a common denominator. Let me rewrite this minus 1/2 as a minus 3/6, right? Minus 1/2 is the same as minus 3/6. So this is going to give me minus 5, minus 3 of them is minus 8 of them, minus 8/6. Over, here in the bottom, make 2 marks, plus a positive. 1/3 plus 4/3, already have a common denominator. That's a total of 5/3. I'm going to go ahead while I'm at it, just to make life a little easier on myself. Let me reduce this 8/6. Negative 8/6 reduces to negative 4/3. Now, this big fraction bar, it's just a division sign, right? In other words, this is simply negative 4/3 divided by 5/3. How do you divide fractions? Flip and multiply. Leave the first fraction alone. And instead of dividing by the second fraction, flip and multiply. Multiply by its reciprocal. Now that we're multiplying, we can cross cancel. And finally we get negative 4/5. Negative 4/5. So as we expected, it does have a negative slope. What does this slope tell me? I could think of that as negative 4 over positive 5 or positive 4 over negative 5. And it's basically saying that every time I go from one point to the next, if I go down 4 units and over 5, that'll put me right back on the line. So my line would look something like this. Or if I do what? If I go up 4, I can go back in the negative direction 5. If I were to go up 4, 1, 2, 3, 4, and back 5, 1, 2, 3, 4, 5, same deal. Same deal. Now in number 44, we're given an equation. We're given an equation of the line, and we are asked to find its slope. I'm going to show you one way to do this, and then I'm going to show you a better way to do this. One way to do this, we know that we can always find the slope if we have 2 points. So let's get 2 points. Let's plug in when x is 0. When x is 0, what's y? That term disappears. When x is 0, what's y? Y is 3. And I think an easy one to plug in would be when x is 1. I'm not looking for intercepts. I'm not trying to graph. I just want a couple of points, and there are infinitely many to choose from. I just want a couple of points so that I can plug into my slope formula. When x is 1, plug 1 in for x. That'll give me what? 2 plus 3, which is 5. So y is 5. So there's a couple points. Your slope is the change in y per change in x. I'm going to call this top one my first point, this bottom one my second point. So I'm going to subtract, in each case, the bottom minus the top. Okay? 5 minus 3, my difference in the y's. My difference in the x's, 1 minus 0. That'll give me 2 over 1, which is simply 2. So the slope of this line is 2. And what we discover is that the slope was right there looking at us the whole time. In other words, if the equation is solved for y already, if the equation is solved for y, then the slope is the coefficient on x. Page 229, the blue box. Page 229. In the blue box it says finding the slope of a line from its equation. Step 1, solve the equation for y if it's not already. Well, this is like our solving literal equations from back in section 2.5, solving formulas for one variable in terms of the others. Solve the equation for y. This one already happened to be here on the board. Then what? Step 2, the slope is the coefficient on x. Nice. So if I'm given this problem, I don't need to go through all this each time. It turns out that once the equation is solved for y, the slope is simply the coefficient on x. Done. Done. Number 50. Here we have a linear equation in 2 variables in standard form, remember? And we want to find the slope given that equation. I could do what I did last time and find a couple of points and plug them in, but if I can get this solved for y, I can just very quickly read the slope right off the equation. Let's solve this for y. Solve this for y. Try to get y by itself on one side. Add 2x to both sides. Add 2x to both sides. That gives me 4y equals, And those are unlike terms, so don't try to put them together. 2x plus 5, that's the best we can say. And then divide both sides by 4. Now think about this for just a second. Dividing both sides by 4 is the same as multiplying both sides by 1/4. Multiplying both sides by 1/4. If I were to multiply both sides by 1/4, I would distribute that 1/4 to each of the two terms here on the right. I would distribute. Well, I can do that without going completely nuts. To divide both sides by 4 is to divide every term by 4, because we're actually distributing that division. It would initially look like this. Divide both sides by 4. But when I divide multiple terms by a number, I can distribute that division, and it's the same as dividing every term by that number. So that's going to give me simply y equals 2 over 4 is 1/2 times that x. Don't let that x rest on the ground. He's not in the denominator. And plus 5/4. What's the slope of this line? Right there, 1/2. Let me show you something else. I want to do a problem like this again, but let me do it generically this time. Let's go back to just our basic standard form. A, B, and C are numbers. X and Y are my variables. And solve this for Y. Solve this for Y. Subtract AX from both sides. Subtract AX from both sides. And divide both sides by B. To divide both sides by B is what? We can distribute and say that means to divide every term by B, which gives me y equals negative a over b times x plus c over b. And look at that right there. The slope of this line is negative a over b. Negative a over b. I'm going to give you a blue box. Okay? If your equation is in standard form, then the slope of that line is negative a over b. That's handy. Understand what I just did here and the power of mathematics. I solved this generic equation in two variables for y. In other words, what I've just done is I have solved all infinitely many possible equations, linear in two variables. I have solved them all for y. Every one of the infinitely many linear equations in two variables given in standard form, I have solved them all infinitely many of them for y. And I have found once and for all what that slope's going to be. Let's go back and look at number 50, keeping our blue box in mind. This blue box that I've given you here on the board. Number 50, we worked it just a minute ago. We solved for y and found the slope was positive 1/2. When we solved for y, we found the coefficient on x to be positive 1/2. Well, guess what? I just solved all equations for y. And I discovered that if I have an equation given in standard form, the slope will always be negative a over b. If I use that here, a is the coefficient on x, b is the coefficient on y. This is going to be negative. A is negative 2. B is positive 4. Negative times a negative is positive, and reduce that 2/4 to 1/2. Done. Nothing to it. Feel free to use this formula if you like. She does not present that formula at this time here in our textbook, but I find that to be a very powerful tool when we're looking at slopes of lines. Number 54. Number 54. Find the slope of this line given its equation. Y equals 4. Well, it's already solved for y. What's the coefficient on x? If you cannot see the x term, then its coefficient must have been what? 0. So the slope of this line is 0. Does that make sense? Well, sure. What kind of line is this? This is the line that passes through 4 on the y-axis. This is that horizontal line that passes through 4 on the y-axis. And we know that all horizontal lines have a slope of 0. So yeah, that makes perfect sense. What about number 56? Number 56, we have the equation x equals -2. All right, solve that for y. You can't. You can't. Well, I mean, you could try. You could say, well, that must be a 0y. Since I can't see the y term, must be a 0y. Subtract x from both sides. And divide. Now, you're not allowed to divide both sides of an equation by 0. But if we were to, what would be the coefficient on x? Something over 0, which is undefined. Would we expect this line to have an undefined slope or no slope? Sure, because this is what? This is the line that passes through -2 on my x-axis. This is the vertical line that passes through -2 on my x-axis. All of the x's, all of the x coordinates of all the points will be -2. That happens on this vertical line. And we know that vertical lines have slopes that are undefined. Or again, you're welcome to say that this line has no slope. You check in the back, and she will say the slope is undefined. But most of the time you will hear me say no slope. On a quiz or a test, if I were giving multiple choice, I would use the language of the textbook and use the word undefined. If you're filling in a blank in a short answer or doing a show your work and you use the terminology no slope, that's fine. That's fine. Now at this point you may want to pause here and see what you think about the homework as assigned up through number 63. Because we're about to look at something a little different. So, if you want to take a lecture break here, you can look at the homework up through number 63. And then come back and go on with the lecture. So the next thing I'm going to look at now are comparing two lines using their slopes. Comparing two lines using their slopes. From geometry, you remember what it means to have parallel lines? Parallel lines are lines that never intersect. The symbol for parallel looks like that. And when I have parallel lines, call this line 1, call that line 2, what can I say about their slopes? Well, look at their steepnesses. What would you expect to learn about the slopes of these two lines? Well, they have the same slant. They have the same steepness. They're leaning the same direction. They have the same slopes. Parallel lines have the same slopes. The slopes of parallel lines are equal. Do you remember perpendicular lines? There's my symbol for perpendicular. And if I have perpendicular lines, what does that mean? I have lines that are meeting at a right angle, at a 90-degree angle. As we consider the slopes of perpendicular lines, I want you to consider this. Consider a rise and a run, an up and an over. Up and over. Let's call my rise, that value, let's call it A. And my run, let's call that B. Now, in your mind, pick up this line. I'm going to call this line 1 in this figure. Pick up line 1 and rotate it in your head until it becomes line 2. And take the little triangle with you. Take the little triangle with you as you rotate it. All right? So, this rise is this value B, isn't it? That rise is now the value B for my second line, line 2. And my run, if I'm calling this the rise, then my run is going back. It's going in the negative direction. That would be negative A. So my slope for line 1, rise over run, okay? We went up A over B. And my slope for the second line, we did what? Up B, back A. Up B, back A, so that was a negative A. And what do you see here in this relationship between these two slopes? We notice that these two slopes are opposite reciprocals. If you have perpendicular lines, their slopes will be opposite reciprocals. Opposite meaning one's positive, one's negative. Reciprocal meaning flip it over. But we're doing both. Not just opposites, not just reciprocals, but opposite reciprocals. Change the sign and flip it over. Page 231 in the brown box. It says two lines with the same slope are parallel. That made sense to us. Then she says two lines whose slopes have a product of -1 are perpendicular. A product of -1. Well, look at my two slopes here. A over B times negative B over A. A positive times a negative is negative. The B's cancel, the A's cancel, to leave what? 1 over 1, which is 1. Everything cancels to leave that multiplicative nothing, the 1. And a positive times a negative is negative. So what she says is absolutely correct. The product of those slopes will be -1. I like to think of it this way, that the slopes will be opposite reciprocals. She and I are saying the same thing. Just two different ways of saying that same relationship between the slopes of perpendicular lines. Look at number 66. In number 66, we're asked to find the slope of a line whose graph is, part A, parallel to the graph of -5x plus y equals -3. And then part B, we're going to be asked for perpendicular to that same thing. What is the slope of a line that's parallel to this guy? I'm not going to graph him. All I need is his slope. Two ways to do that I've shown you. Solve for y. That's very easy in this case. Solve for y. Add 5x to both sides. Right there. The slope of the given line is positive 5. So the slope of the line parallel to that line, parallel lines have what? The same slope. So there's part A. I said there were a couple ways to find this. We could have also done what? We could have said that the slope, because that's in standard form, the slope is negative a over b, which is negative 5 over 1, which is positive 5. Either way, solve for y or use negative a over b, but find that slope and then answer the question, what would be the slope of a line parallel to the given line? And then part B says, what is the slope of a line that is perpendicular to this given line? Well, we've already found the slope of the given line. The slope of this line is positive 5. What is the slope of a line that is perpendicular to the given line? It's going to be the opposite reciprocal of 5. Opposite means change the sign. Reciprocal means flip it over. So the slope of a line that is perpendicular to this given line is going to be negative 1/5. Negative 1/5. Look at number 70. In number 70, we're given a pair of equations. And the instructions say for each pair of equations, give the slopes of the lines, and then determine whether the two lines are parallel, perpendicular, or neither. I'm in the habit of, when I have a pair of equations that are related, you'll see me put a curly brace in front of them. No big deal. It's more of a habit of mine. Nothing wrong with it, nothing wrong with not having it. So I have this pair of lines. She says, first, find the slope. First, find the slope. I've shown you two ways to do that. Let's work this one by solving for y. Okay? Take our first equation and solve it for y. Add 4x to both sides. Add 4x to both sides. And divide both sides by 3. Divide both sides by 3. That is, divide every term by 3, because it's like distributing that division. So we have y equals 4/3 x plus 4/3. The slope of the first line is 4/3. What's the slope of the second line? Solve it for y. Slope of the second line, solve it for y. Add 8x to both sides. Add 8x to both sides. 8x plus 0 is just 8x. And divide both sides by 6 to find that y equals, go ahead and reduce that, 8 over 6 reduces to 4/3 times that x. The slope of the second line is 4/3. What does that tell you about the relationship between these two lines? Are they parallel? Are they perpendicular? Are they neither? These two lines have the same slope. Lines with the same slope are parallel. This makes a fun multiple choice. I would put, determine the relationship between the two lines. Are they A, parallel, B, perpendicular, C, neither, and then for D, I'd put both, parallel and perpendicular. which of course is impossible. Lines can't be parallel and perpendicular at the same time. But somebody will pick it. Somebody will pick D, and then E, none of these, which it's got to be one of the first three. It's parallel, perpendicular, or neither parallel nor perpendicular. But somebody will pick E also. They're either parallel or perpendicular or neither parallel nor perpendicular. Only those three choices. Let's do number 72. Number 72. Okay, this time, let's use that other method of finding the slope. And I don't care which one you use. I think you should know them both. Sometimes one is handier than the other. In the previous problem, we brought each one of these down and solved for y. But I gave you a blue box that said the slope, if the equations are already in standard form, and these are, the slope is negative a over b. So for my first line, that's going to be negative, the coefficient on x is 5, over, the coefficient on x is negative 3. The slope of the first line is going to be what? Positive 5/3. Slope of my second line using negative a over b. I could solve these for y and I'd get the same slopes. We know that. So whichever method you want, the one I did before where I solved for y, or this one I'm doing now, negative a over b. Either way, I think you should know both because they're each handy in their own time. Negative a over b, that's going to be negative. The coefficient on x is 3 over. The coefficient on y is negative 5. That's going to give me a positive 3/5. So I found the slope of both lines. Are these two lines parallel? No. The slopes are not the same. So these two lines are not parallel. Are these two lines perpendicular? No. Perpendicular lines have slopes that are what? Opposite reciprocals. These slopes are just reciprocals. For these to be perpendicular, I'd need one positive, one negative, wouldn't I? They would have to be opposite in sign and flipped over. So they're not perpendicular. They're neither. So let's do one more. Number 74. This would be a good one for you to try on your own. Once we get this written up here, you can pause the video, give this a try, and then come back and we will compare answers. And it doesn't matter to me whether you use the method of solving for y to find your slope, or, as these are both already in standard form, negative a over b. If you want to know what I'm going to do, when they're in standard form, the slickest thing is negative a over b. But you go about it either method, come back and we'll compare answers. I said I'm going to use negative a over b. So my first equation is going to give me a slope of negative. A is 3. B is negative 5. That's positive 3/5. My second equation, using negative a over b, that's going to be a negative. A is 5. B is 3. There's my slope. So my slopes are positive 3/5 and negative 5/3. Are they the same? No. So these lines are not parallel. Are these opposite reciprocals? Are they opposite in sign and flipped over from each other? Yes. And so these two lines are perpendicular. The next two sections, we are really going to use everything that we've put together here in these first three sections. So get these first three sections down solid as we get ready to continue on into the next two sections of this chapter. And if you pause the video earlier, well, you've got what? 6 problems left to finish the homework. And if you didn't pause it, well, you got them all. So I'll let you get started on that.